So this notebook we are presenting today is kind of an aggregation or a summary of what we have done in the last 8 weeks, so to speak. We started with phenology, where we presented both in English in the first week and French in the second week. And then we went on to rainfall anomaly in English and French, vegetation anomalies as well as soil moisture. So in this notebook, we want to kind of bring up, it's sort of a summary of what we did in the previous notebooks. It's a good way for those who were not part of all of those notebooks to catch up with what we were able to do and kind of give an indication of how we can extract some information on crop health from the analysis we did in the previous notebooks. So this notebook is available on the real world examples folder on the Sandbox, and so you can have access to it, but this would also be made available for anybody who is interested in working with it. Now, to get started, like I said, this notebook is kind of a recap of what was done in the previous notebooks. So the first thing we are going to do is to bring in import our data sets, the data cube, the GeoPandas. We're bringing in the Matplot library for the dates and for the plotting. We're also bringing in the images, the NumPy, the pandas, and the XRA. Now, one key thing about this particular notebook is that it is calling on the results of the previous notebooks. Now, if you look on this side where my cursor is, you can see the previous notebooks that we ran. And you can also see two folders there. There is the DAX worked folder as well as the results. Now, the results from all the previous notebooks are saved in this result folder. And this notebook basically calls on those results and brings them together. So in the first cell, we have imported our data sets. Now we also want to now define the area or the period of study. Now remember, in the previous notebooks, most of the periods we're working with was between 2017 and 2020. And that is the periods we are defining here. Now also note that our data set was saved into the directory results. And so all the results that are there, we can call on it using this cell. I'll go ahead and run that. All right. Now, the next thing we will do is to call on the data sets that are in the results directory. Now, we have the results for the rainfall anomaly, which was analyzed in the rainfall anomaly notebook. We call on the NDVI anomaly, which was in the vegetation anomaly notebook. We also call on the soil moisture, which is in the soil moisture notebook. And that is given here. We'll go ahead and run this. Okay, so now we want to load the data. We have called on these results. Now we want to load them. Something we would note about the results we called on here is that they are CSV, which means that they are basically text files, but we would also need to see them as displayed images. So the first one we'll load is that of the phenology. Phenology helps us to understand the seasons or the changes that occur across a year within a vegetation system, be it an agricultural area or a forest area. Now, the phenology, as we have it from our phenology notebook, this is what is given here. Now we can see the start of season, the period for start of season for each of the years, the value of at the peak of the season as well as the end of the season. Now this is data sets for 2017, 2018, 2019, and 2020. Now we see that in 2020, we had the latest start of season. In 2020, we had the latest peak of season as well as the latest end of season. And 2017 basically had the earliest start of season. 2019 had the highest peak of the season. And the end of season was basically the same for all of them. So this shows us the phenology of the area of study, which is just a part of JOS. And we can go ahead in the next cell to display the phenology for 1 year based on the pixel per pixel phenology. Now we are going to do that for 2020 as we can see in this script here. And then we are also calling on the results from the output directory for the per pixel phenology, and we'll go ahead and run this. Please hold on a little, it's still running. Okay, so the phenology has run for the per pixel, and this gives us an image display of, or a per pixel based display of the phenology in 2020. And so we can see the day of year of the start of the season, and we can observe that most of the area, the season started from about the 50. The value, the NDVI value at the start of the season, and it's mostly about 0.1. We can see the day of the year of the peak of season. The peak of season is, in most cases, is around the 250, between 200 and 250. The NDVI value at the peak of season. The end of season day, mostly around 300. And then the NDVI value at the end of season, which is mostly between 0.2 and 0.0. And of course, we have the length of season. Most of the area had a season length of between 200 and 250 days. The amplitude of the season, the NDVI amplitude, the rate of senescence, and the rate of growth of plants in the area. Rate of senescence has to do with the rate of dryness of vegetation in the area, and the rate of growth is the rate at which, or rate of greenness of the area. So this is the phenology of our study area. Now we'll go ahead and load the rainfall anomaly data of the same study area. Using the code here, we'll just run this code, which will load the rainfall anomaly for the study area. Now, remember we said it's based on the results gotten from the rainfall anomaly notebook. Now, this shows us the total rainfall between 2017 and 2020. And of course, you have low rainfall in the earlier months of the year, between January and about March or April. And then it starts to peak about August in the year and goes down again towards the end of the year. And this is observable across all the years, even though we can see that in 2017, there seems to be a little higher rainfall, given the height of the graph here compared to the other years. Now let's go ahead and load the per pixel rainfall anomaly analysis by running the next cell. Right. Now this shows us the rainfall anomaly for our study area between 2019 and 2020. And given that this is based on anomaly, it's showing us how much it deviates from the normal value of rainfall compared to between 1980 and 2011, which was our base period. Now, this is showing us that in October 2019, we had a high anomaly, probably had much more rainfall than would have been expected. While in periods like February 2020, we had much less rainfall than would have been expected, or than the normal of the period we had chosen. So this gives us an indication of the per pixel anomaly and shows us which months we had more rainfall than normal and which months we had less rainfall than normal. So we have looked at the phenology, and we have also looked at the rainfall anomaly. Let's go ahead and look at the NDVI anomaly. Now, this next cell is going to run the NDVI to call on the data set for the NDVI anomaly for the same study area. So here is the NDVI, monthly NDVI, plotted for the study area between 2017 and 2021 in this case. Well, basically end of 2020 to start of 2021. And we can see almost equivalence in the graph. However, there is a slight reduction in the 2020 graph, as you can see here. Now let's go ahead and also plot that of the surface moisture, the root surface and root zone moisture. So we'll bring this in using this next cell, and we'll run that. Okay, so here is the graph showing us the surface moisture and root zone moisture for our study area, showing that at the drier months of the year, which is usually between January and about May, you have the lowest values of root zone moisture, and it increases as you go into the middle of the year, the peak of the year, which is about July, between July and October or September, and then it starts to drop again to the end of the year and so on. So it's we can almost see a similar relationship from 2017 to 2020. However, we are also seeing that in 2017, there were higher values of soil moisture than in subsequent years. However, 2019 seemed to have the next higher value in surface moisture compared to the 2018. So we can also bring that of root zone moisture. Yeah, just a moment, please. Sorry, I had a break in the internet, so I have to restart the connection.
Thank you so much, Professor. In the meantime, maybe the participants could ask a question as like a small commercial break. Also recognizing Professor Soma, Afrigist, Maud, my colleague here, Edward, Joseph, and Celestine. Celestine,
good afternoon, Doctor.
Yes, Professor.
Good to hear you.
Yes, please. Looking forward to your presentation next week in French.
By the grace of God, we are getting ready.
Inshallah.
Inshallah.
Thank you so much. Also recognizing Elsie Chana, calling from France.
Hi, Kenneth. Hi, everyone.
Welcome so much. Also recognizing our colleague Lisong from CSC and colleagues from Africa Women in GIS, Jeanette Amakuru.
Omakoroni Meza. How are you, everyone?
Welcome so much, Janet. Professor, how are things looking?
Yeah, coming up. I don't, is my screen still visible?
He's still coming. That's why we're entertaining the
Okay.
participants.
Okay.
Also recognizing Elijah Mukata from Zambia, calling from Lusaka.
Hi, everyone.
How are you, Elijah? How is the experience so far with the learning platform?
It's okay. Can you hear me?
We can hear you very well from the village.
Yeah, it's okay. At least I'm learning a lot.
Well, thank you so much for connecting with us. As you can see, we are a team of young people and we are mixing with everybody to have an experience. Recognizing also Dr. Keleboge from Botswana.
Hello, everybody.
Welcome so much to Keleboge. She's calling from Okavango Delta in Botswana. Also recognizing my colleagues, yourself.
Hello, everyone.
Yes, Anis, how are things in Tunis?
All is good, thanks.
That's so nice. We are waiting for a presentation very soon, inshallah.
Inshallah.
Okay. Thank you so much, Anis.
Thank you.
Professor Phoebe, how are things?
Yeah, we're back. We're back.
Oh, thank you so much. Over to you, please.
All right. So just before the interruption, we're able to bring in the surface moisture and root zone moisture. Now we are bringing in a sort of comparison between the precipitation, which is the amount of rainfall, and the root zone wetness. Now this graph shows us the root zone wetness and surface moisture on the same graph with the amount of precipitation. And we can clearly see that in the periods of the years when we had the low precipitation, we had low root zone moisture and surface wetness. And as the rainfall increased, we could see an increase in root zone wetness and surface moisture. However, even when it started to come down, we still have some highs in the surface moisture and root zone wetness, which gradually started to drop towards about the end of the year, about December, January, right? And so we have that across the years. Now in the next cell, we are going to plot the NDVI and rainfall anomalies. Now this will just show us in a graph how much deviation from the normal both rainfall and NDVI had across the years. And so we'll run that. All right, so our result here is showing us both the NDVI anomaly, which is given here, which just shows how much the NDVI deviated from the normal across our period of study, 2017 to 2020, and how the rainfall also deviated from the normal between 2017 and 2020. And we can see that mostly vegetation had a lot of reds, which means there were a lot of periods of unusual dryness, but we also had periods of higher anomalies, which means that there were better vegetation or better NDVI values in certain periods of the year. Likewise, the rainfall, we can see those areas that are blue showing us those areas where those points, those months when we had better rainfall than the normal, and those in red showing us areas where or months where we had not as good rainfall as the normal. So in this next cell, we are going to kind of be bringing our rainfall, the soil moisture, and NDVI together to be able to see how they relate to together. And so we're going to run this cell. And there we have it. We have the relationship between the total rainfall, the NDVI values in the green line, and the relative surface wetness in the yellow line. Now we can clearly see at what times of the year, this is between 2017 and 2020, when we had low NDVI values, and those corresponded to the times when we had low surface wetness as well as low rainfall. And we can see that as rainfall increased, we had higher NDVI values and higher surface wetness. But another thing we took note of, which gives us some kind of indication of crop health in this area, is that there was really no time of the year when we had surface wetness and NDVI having values below 0. So almost all through the year, we're having values that are from 0.1, 0.2 and higher. And so it gives us an indication that this area has almost constant value for soil wetness and almost a constant value for vegetation greenness, which kind of gives an indication that this area probably has all year round agriculture, even though it's obvious that at certain periods of the year, which is in the periods when we have the highest amount of rainfall, that's between May and about September in the year, you have the highest amount of greenness, highest amount of soil moisture, and of course the highest amount of rainfall. And that is consistent through all the years as shown in our data sets. So this gives us some indication of the nature of crop health in the area. For further studies or for further information, we may want to consider maybe individual crop requirements for NDVI, surface moisture and rainfall, and see how they perform given this base data sets that we have. So this can be referred to as a base kind of data, and we can build on this for future purposes to be able to understand how individual crop health performs, or individual crops performs with relation to NDVI and surface wetness as well as total rainfall. So thank you everyone, and please send your questions my way. Thank you, Ken.
Oh, thank you so much, Professor. The students are actually clapping for you. They could have some questions, but I think this is the best combined notebook for everybody. And I'll be able to share this a notebook with everybody because I've realized it's not in the normal directory. We'll work with Edward to make sure it's delivered in everybody's inbox. Colleagues, participants, any questions for Dr. Phoebe? In case you don't have a question, we can also, it can be a compliment or something that you would like to see from your different experiences. You're interested in looking at the crops somewhere. This use case was for somewhere around Batin in Nigeria. We could have some crops.
What is the average rainfall? Because I see that throughout the year you don't have deficiency in moisture as indicated.
Sorry, I didn't get that. Please, could you come again?
I think the professor was asking that there's some consistency of the rainfall all year round, and maybe she's calling from Botswana where the rainy season is a little bit different. I think it goes from November to March once a year, and around the equator, I think there are 2 seasons, like around Rwanda, Burundi, and in West Africa, it's a different season.
Okay, we can see, Ken, can you hear me? I didn't get what you said.
Yes, I was saying that she's calling from Botswana where they have a different rain pattern. They normally have the rains from November to March. That is the case of Botswana. And
Okay.
This is an example of Nigeria where it could be that I suspect there could be 2 seasons of rainfall.
Oh no, if you observe this graph, you'd see that in most parts or most times in the year, you are having higher rainfall from about April, that's 4th, right, to about October. Now, these are the periods when that's the rainy season in Nigeria or in most parts of Nigeria. Now, even though at every month there is some seemingly some values of precipitation, you can observe that in about January and February, we're having values of about 0, which means that those are the driest months of the year. And in this area, they are dry. However, even though these months appear to be dry and having values of about 0, we are saying that there are some values of relative wetness. And that's because there is a water body in that area. Let me just scroll up and show you the phenology data sets. Okay. So if you look at this phenology data sets, you see this feature here is a water body. And so it's possible that even in the drier seasons, there is some kind of irrigation farming. And so there is some supply of water. And so that's why there is not, we are seeing some value for surface wetness, even though it's the period when there is no rainfall. And so you can see that even though it's no rainfall, we still have surface wetness of at least 0.1, which indicates that there must be some agricultural activity still going on even in the dry months. And that is true for all the years within the study. So the rainfall season is usually between April and September across in most parts of the country. Of course, in the real northern parts of the country, like Bauchi State, those are the areas that are closer to Niger and so on. Those areas, you might have a shorter rainfall window. In the areas towards the south, like in Calabar, those areas closer to the Atlantic Ocean, you have so I hope that answers the question.